Okay, perfect. So welcome everybody to our fifth ever live science show. Today's theme is going to be on sports science, so we hope that you really enjoy it. All of these activities are obviously geared towards sports science, which is one of the sciences that don't really get too much attention in the whole world of STEM. So we decided to do this science show just to promote it a little more, especially myself as a kinesiology graduate. Um, it means a lot to me. So I hope you guys enjoy it. Obviously, Isabella is not here, otherwise she would be hosting it right now. So just bear with us, stay with us, and I hope you enjoy the show. So first up, we have Stass with his activity.
All right, so hi guys. So my activity is called fulcrum forces, and basically a fulcrum is just a point on which a lever is supported and on which it pivots. So fulcrums are everywhere in nature and in the human body. So your fulcrums in your body are basically classified into three portions. You have your joint, which acts as the fulcrum itself. That's the point of rotation for a muscle or a bone. Then you have the load-bearing portion, or the lever, which is the bone itself. So in your arm, your long bone is called your humerus, and that would be, there's a joint at the top that connects it to your shoulder. And then the portion, there's just tons of muscle surrounding it, right? Muscle, tendons, ligaments. That's called soft tissue. And all of this stuff together allows us to move. So the balance of forces in the human body is super, super important. And when people pull their hamstring, or you pull your muscle, or some people tear their ACL, that kind of stuff in sports injuries, a lot of the times that's happened just because they've exerted a force that's too much for the levers in their body. And the other side of the lever tries to overcompensate. And then the muscle's just taken off the attachment point at the joint or the fulcrum. So the activity I'm going to show you guys is kind of a two-parter. There's two things you can do to kind of see this. This is just a can of soup. You can use any cylindrical object to see this. And if you roll it like that, that kind of emulates the motion that your joints would have. They're very free, right? So, and this would be the load-bearing portion or the lever. So this would be skeletal muscle, right? And muscle and skeleton, muscle and bone together, skeletal muscle. So on this part, you can see here, if I have a little eraser, that's one portion of weight on the lever that I can counterbalance here. So your muscle would exert a force. If you were grabbing something, for example, your muscle would exert a force equal to that on the other side to make sure that it doesn't fall out of your hand and you can actually move it like this. Then here's a 2.5-pound plate. Now you can see that I have to carefully exert a larger force to keep this up because it's heavier. If you get something, hey, that's too big for your thing. As you can see here, this 10-pound dumbbell is not very good for this little ruler, right? And it's bending. And if I leave it for too long, it'll snap. And that's how people either rip muscles or break bones. So what we do have in our body, though, because joints can't be super free, is tendons and ligaments, which is tape in this case. So you just pop her there, put it on. There you go. Assert yourself. And you do the same thing. So then you can't move it as freely, but there is some range of motion that you'd still have. Just like you can't rotate your shoulder 360 degrees around like this way. That'd be real creepy, although some people can do that and they're contortionists. Amazing talent. We'll look into that later. So that's basically what you can do. So challenge your siblings or your family and see how much weight they can hold with a ruler and a soup can and see how good their balance is. Another thing you can try doing is, if you have like little dumbbells or weights or anything heavy in your house, watch when you change the lever arm of your fulcrum. So if I have this dumbbell, it's way easier to hold here unless I hold it out there. Now that I've lengthened the lever arm, you can't actually move it as well. It's 10 pounds isn't very heavy, but it feels way heavier than it does here. So the point of all this is to say, lift weights, resistance training, doesn't matter. You don't have to be jacked and huge. Just do some push-ups or something, and that'll keep you healthy, because if your muscles are stronger, then you can exert more force without hurting yourself. So there you go.
Perfect. Thank you, Stass. I think we all learned something about your workout routines and science in general, sports science in general. So anyways, next up we have Michaela, and she's going to be talking to us about reaction time.
All right, hi guys. My activity today is reaction time. So many sports skills require quick reaction time. So for example, think of hitting a really fast ball in baseball, or returning a tennis serve, or blocking a slap shot in hockey. But first, what is reaction time? So reaction time is the amount of time it takes to respond to a stimulus. It's important when driving, when playing sports, in emergency situations, and in many day-to-day activities. Reaction time depends on nerve connections and signal pathways in your body. Reaction time is measured by how long it takes for brain and nerves to react to a stimulus. So is your right hand faster than your left hand? Can you improve your reaction time with practice? And do both hands improve if you practice with one hand? So in today's experiment, we're going to test our own reaction time with a simple experiment. So I need an assistant for this experiment. You may need two people. So I have my trusty assistant here that's going to come. All you're going to do is the person who's being tested is going to hold their hand out like this in a little C form. And the ruler is going to kind of sit in between. You're going to have your eyes closed, and the person helping to test your reaction time is going to release the ruler while they tap you on the shoulder. So you're going to try and clamp the ruler as fast as you can. I'm not very good at this. My reaction time's pretty slow, so sometimes I miss. We're going to try our best. So my assistant is going to drop the ruler and tap my shoulder at the same time. Okay, pretty good. So something you can use to measure is the little numbers on the ruler. So if you keep the 0 at the bottom, and then when you release it, you can measure how long it took you to use your reaction time and catch the ruler. That's all I have.
All right, perfect. So next up, we have Katie, and she's going to do some sort of activity with a floating balloon.
Hi guys, I'm Katie. Today, I'm going to be teaching you about the Bernoulli principle. So basically what this is it's what allows objects to float through the air. So this is super important in sports because this is what allows us to keep like the tennis ball like in the air so then you can hit it back and forth, or like a badminton birdie. This is what allows those objects to stay. Or if you're shooting like a 3-pointer in basketball and you need to get it really far over, you need this principle to keep it in the air. So how this works is you have your object here, and when the air comes underneath it, the air will actually move faster underneath the object than it will on top. So this will allow it to remain suspended in the air. So this is like the same principle that would work with like a bird or a plane, for example. And also, because of the shape of the balloon, oh my gosh, because of the shape of the balloon, when the air is moving underneath it, it'll allow it to stay floating because it's aerodynamic. So as you can see here, as is like the same with any sports ball, with like a basketball or a baseball or anything like that, they're all very round. So they're shaped this way to be aerodynamic. So this allows the air to flow past them and like keep it suspended without dragging off of anything or like hitting any edges or any rough spots like that. So this is the same thing that like if you see swimmers, like Michael Phelps, for example, how they wear like the swim cap on their head because this allows them to be more aerodynamic through the water. And then it's the same as like those bike helmets that are very smooth because then this will allow the bikers to go really fast. So I'm going to show you the Bernoulli principle in action. So I have my hairdryer and I have my balloon. Sometimes it's a bit tricky to keep the balloon up, so just bear with me, but I'm going to show you how the air will flow around the balloon to keep it suspended. So just bear with me. I'm sorry if it doesn't work. Okay, so I think my hairdryer is just a little bit too powerful for what I'm trying to show you guys, but what should happen here is the balloon is supposed to remain suspended because the air will go like flow underneath it and flow around it. So this will actually allow it to float in the air. But my blow dryer is just a little bit too high tech, so I don't think it's gonna be, oh. Here we go. Yeah, so my air dryer is just a little bit too powerful, so it's not going to work today. Thank you for watching anyways, and I hope you understand what I was trying to show you. Okay, back to you, Michael.
Perfect. Thanks, Katie. Maybe next time we could try using Stass's hairdryer. But anyways, up next we have Alexandra, and she's going to be talking about dominant sides in human bodies.
All right. Hi, everyone. I'm Alexandra. So before we start talking about sports and dominant side in sports, first we're going to talk a little bit about language and the brain. So in the vast majority of people, the side that contains the area important for language is the left side of our brain. So you may or may not know that people have dominant parts of their body for other jobs too. Like, for example, about 85% to 90% of the population is right-handed. So this, in other words, this means that your right hand is dominant, and that right-handed people obviously like to use their right hand for most tasks. But what about our feet or our ears or our eyes? Do you know which one of your feet is dominant, or which eye or which ear? So before we get into a few experiments how to test for that, I should just mention that the exact reason why most people are right-handed isn't completely understood by scientists yet. And some people think it has to do with language, because most people are right-handed. And this is a trait that for the most part is controlled by the left side of our brain. And the left side of our brain is also what controls a language in the left-hand hemisphere. So this might suggest that as the left hemisphere evolved for language, it also evolved and created a specialization or preference for the right hand to use to do tasks. So back to what I was saying before about the feet and the eyes and all that. So about 80% of people, their right foot is dominant, and 70% favor the right eye. And this is lower than right-handedness because your body has a little bit more freedom of choice to choose which foot or eye could be dominant versus that of your favored hand. So we're going to do a few tests that you can ask your parents or siblings or friends to try or even just try them yourself to see which body parts are dominant. So the first thing we're going to do, we're going to check right or left-handedness. So that one is fairly simple. You can get people to pick up a pen and have them write their name, and then you can, if you want, you can make a table or something and chart it all down, but just ask them when they're signing their name, would they use their right hand or their left hand? Another thing you can do is get people, careful with scissors, but you can get people to cut a piece of paper, and some people might use their right hand, some people might use their left hand. And then another thing you can do is take a ball. I know you usually don't throw a tennis ball, but you can take a ball and throw it to somebody and see what hand they use to throw it back. So the next thing you can do to check for a dominant eye is you can take a piece of paper and then you can roll it up, or if you have a toilet paper tube or something, you can do this too. If you give it to somebody and ask them to look at a tree over there, and they'll usually put it up to one eye, and that is usually their dominant eye. And the other thing you can do, same thing, is take a piece of paper and cut a little circle in the middle. Look at one object far away, but make sure you're holding the paper far from you. And then ask the person to start moving the paper closer and closer to their face, but still looking at the object. And usually what they'll do is, without realizing it, as they pull the paper closer, they'll move the paper closer to one eye. So eventually they're only looking out of one eye. And this is usually the dominant eye. So last thing, we're going to check for a dominant ear. So you can do this a few different ways. You can pretend that you have to tell somebody a secret and ask them to cup one side of their ear so they can hear better. And usually whichever ear they do this on is their dominant ear. So there's all kinds of different tests you can do. Same thing with your feet. Ask somebody to kick a ball or put something on the ground and ask them to step on it, and that's their dominant foot. So just quickly, when we're talking about sports, it's important to think about what are some possible advantages or disadvantages to people having a dominant foot or dominant hand. So obviously for left-handed people, some tools or writing materials are more designed for right-handed people. An interesting fact, sports fact, in 2009, only 7% of the players in the NBA were left-handed, but in 2008, around 26% of pitchers in the MLB were left-handed. So it's interesting to think about, is it better to be left-handed in some sports or others? It's also cool to find out in other people what side is dominant, so then that might give you an advantage in the sport if you know that one side is weaker, or even people's forehand versus backhand, say in tennis, like that, something like that. So overall, everyone has a dominant side, other than if you're ambidextrous, which means that both sides have an equal, or that they can use both sides with equal skill. So give it a try at home and test these experiments on your friends and family, and yeah, have fun.
All right, perfect. Thank you for that, Alexandra. That was really interesting. So up next and up last that we have Amy here, and she's going to be teaching us a little bit about foosball, which is in fact an Olympic sport.
Thank you, Michael. So yes, as Michael said, I'm going to show you guys how I made this little DIY foosball table, just so we can explore how we use forces and Newton's laws of motion in everyday sports such as soccer, and which I just learned foosball is in fact a sport. So even foosball is a sport. All right, so before we go into, I'm going to explain the physics behind it after we make our little box, just so I can explain it better. So for this little foosball table, you're going to need some cardboard box. I've just used this little cookie box that my roommate had, but you can use a cereal box and just cut off the bottom of it. Then what I've done is just cut some 4-centimeter slits into the box, and you may need some parent help with this. It was a little tricky. And then afterwards, I just taped it back together like so. So we basically just have a hole on one end for our goal post, and then a hole on the other end. Then what you're going to need is some kind of sharp object, and definitely some parents help for this, to just poke some holes into the side of our box here. And you want to do that on each side of our box like so. And then you're just going to grab some straws and poke it through our holes to make our little foosball stick things. And then I've just taken some cardboard, put a little, you can decorate it how you like. I just drew these little guys on there, secure it with a paper clip, and you've got yourself a little foosball table. So now I'm just going to flip my camera so I can explain the physics behind this. All right, so we've got our little thing set up here. And so we're first just going to talk about a force, which is a push or pull on an object that changes its shape and motion. And to describe a force, we use the direction and strength. So for example, in soccer, when we kick a ball, so here's my little ball here, the harder we exert, the more force we exert on the ball, the farther it will go. So if I move my little figure back just a little bit, my ball barely moves. But then if I exert a bigger force by pushing it back further, wow, it goes so far. So that is just one concept. And Newton's first law says that any object in motion will continue to move in the same direction unless another force acts upon it. So this basically just means if I have my little goalkeeper here and I exert, and oh, it stopped. That's because I've had another force exerting on it. And Newton's second law states that the greater the mass of an object, the more force it will take to accelerate the objects, which means that the harder we kick a ball, the farther it will go. It also means that the heavier our object, the more force we need in order to move the object. So this is a tiny little ball here, and then I've got a bigger ball. So if you look, if I put the same amount of pressure I did before, oh, missed it. It does not go as far as our smaller ball. Uh-oh, technical difficulties. All right, we're back. But yes, if I want my ball to go as far as my little ball goes, I have to put more force by winding my guy up further in order to make it go farther. But in this case, I just have my little goalie blocking it. But if I move my goalie out of the way, wow, so far. And finally, Newton's third law states that for every action, there's an equal and opposite reaction. And this means there's always forces that are the same. And when we kick a soccer ball, there's a force on our foot on the ball, but there's also the same amount of force of the ball that puts on our foot. And so this is just the opposite direction. So once again, if the force that I'm putting with my little soccer player, the same amount of force is being put on the ball, but in the opposite direction. All right, that's all I've got for my little foosball table. You guys can decorate it as you like. And yeah, back to you, Michael.
Perfect. Thanks, Amy. That was really interesting and fun. I'll be sure to make that later. So anyways, that just about does it for this science show. We're going to be continuing to have science shows next week if we're still working from home. But we should be having some news about our science camp within the coming days. Hopefully by Monday, we'll have some news about what's going to be happening with our science camps this summer. And we'll communicate that to you guys, obviously, right away. So we thank you guys for tuning in. Remember to stay safe, wash your hands, and enjoy the rest of your day. Thank you.